Hello everyone, welcome to the next lecture of Engineering Mechanics. Here we are dealing with Kinematics of Particle. In this lecture we will see the projectile motion in Kinematics of Particle. Let us see what is this projectile motion. So projectile motion means what? The motion covered by any projectile, or when we are projecting some of the particle, then some path is covered by that particle, which is called as the projectile motion, and that path is the parabolic path. Like here you can see this ball is projected from one point, so because of the gravity it has reached to the ground after some time. So within that time it has covered this path, which is the parabolic path, and this solid line, it is representing the velocity at those different points. So that practical application we can consider, like this ball is projected and here it is reaching to the ground, so it is forming that parabolic path. So and here whatever the acceleration is there, it is because of the gravitational acceleration. Air resistance and other parts are neglected in this projectile motion. So only because of the gravity that acceleration will be considered. So let us see some basic terms related with this projectile motion. So in these basic terms, the first of all, that position of the particle we are defining along that parabolic path with this in the vector form, that xi plus yj bar. Let us say this is the parabolic path which is covered by some particle. So at any point on this path, its position will be referred as, with the help of this position vector, as xi bar plus yj bar. So this particle is projected with its initial velocity u with an inclination theta with respect to the horizontal, that is with respect to the ground. So u is the initial velocity and theta is the angle of projection by which this particle is projected. So after defining that position of any point on this parabolic path in the vector form, then that similarly the velocity can also be given for this initial velocity as we are defining u. So for this initial velocity, its vector form will be this u cos theta I plus u sin theta j. And as initially we stated that here acceleration is only because of the gravity. Hence that acceleration due to gravity, that is shown with the acceleration vector as minus g into j. So based on this acceleration, if we are integrating that equation, then we already have seen that acceleration is nothing but the rate of change of velocity, means that dv by dt, it is equal to minus g in vector form minus g into j. Just rearranging the terms and getting its integration, that integration dv is equal to integration minus gj into dt. So solving this integration term, we will get that velocity, and hence the velocity will be minus gt into j plus c1. c1 is the constant of velocity, or that constant of integration. So how to get that constant of integration? So for that we can consider the initial condition, that is at t is equal to 0, v is equal to the initial velocity. Means it is the origin from where we are projecting the particle. It means at that origin t is 0, but as we are projecting the particle with some velocity, it will have this initial velocity. And hence by putting these values in this equation, we will get the equation for velocity. So here we are getting this v is equal to u and t is equal to 0. It means c1 is equal to u, and u that we already have defined in the second equation, that it is equal to u cos theta I plus u sin theta j in terms of vector. So by putting that term into the equation of velocity, we will get that final velocity as this u cos theta I plus u sin theta j minus this term gt into j. So just we can rearrange this term and we can write it in the form of vxi plus v by j. So by that we will get this equation as vx is equal to this u cos theta and vy is equal to u sin theta minus gt. So likewise we can get the velocity components along x direction and along y direction, and based on these components the total magnitude of the velocity can be found out as v is equal to under root of vx square plus vy square. After getting velocity, then to get the position component, we can integrate this equation that velocity is the rate of change of position. Hence integrating it, that equation will get integrated, that u cos theta I, its integration will be taken separately, and u sin theta minus gt into bracket, that bracket multiply with j into dt. So by solving that integration, we will get the term as that ut cos theta I plus ut sin theta j minus gt square by 2j plus c2. So this c2 is the second constant of integration for this position. So how to get this c2? So again we'll need to use that condition that when r is equal to 0, it means position is equal to 0. So it is again referring to the origin where that position is 0, that t is 0, means at that time t is equal to 0, the position will be 0. So just putting these terms, this r is 0 and t is also 0, so we will get c2 as 0. And by putting c2 0, this position vector can be defined as this ut cos theta I plus ut sin theta j minus gt square by 2 into j. And referring this position with respect to the first equation, that r is equal to xi bar plus yj bar, hence x will be taken as ut cos theta and y will be taken as ut sin theta minus gt square by 2. So by using these terms, we are getting all the three terms related with this parabola or related with this projectile motion, that its integration is taken as minus gj, or we can say as it is the integration only because of the gravity, it will be only along y direction and not along the x direction. Hence ay is equal to minus g, and based on this a, we have found out v, that is the velocity. So vx is equal to u cos theta and vy is equal to u sin theta minus gt. Hence the total velocity, magnitude of total velocity will be equal to under root of vx square plus vy square, and in vector form it will be written as vxi plus vyj. Similarly, then we have got the position as r is equal to xi bar plus yj bar, where x is ut cos theta and y is ut sin theta minus gt square by 2. To find the terms related with the projectile motion, that is either to find out the velocity at some instant or to get the position at some instant, these equations will be helpful. Now let us see different terms related with this projectile motion. So the very first one is that angle of projection. What is this angle of projection? It is the angle made by velocity with horizontal. Means here you can see in the diagram that this one is the initial velocity u and it is projected, means the particle is projected with some initial velocity, and this initial velocity is having some inclination with respect to the horizontal one. This inclination is nothing but the angle of projection. It is the angle made by the velocity with this horizontal. If this velocity of the projectile is directed up the horizontal, it is called as the angle of elevation and it is considered as positive. When this velocity of the projectile is directed below the horizontal, then it will be taken as angle of depression and it will be considered as negative. Means as here you can see it is projected up the horizontal, so it is angle of elevation and it will be taken as positive, means theta will be taken as positive. Another case is it can be below the horizontal. In that case it will be angle of depression and this much will be theta, which will be considered as negative. Likewise, that angle of elevation and angle of depression can be differentiated, but both of the things are related with this angle of projection. Then the next term is that time of flight. It is the total time of the motion of the particle, or we can say the time for which that particle is remaining in the space. That is nothing but the total time of flight. It means it is in the same plane from where it was projected. So here we can see in the diagram that first the particle was projected from this point and then after some time it is reaching to this point. So now this much time taken by the particle to traverse this path will be taken as the total time of flight. And in this case, now this y is becoming 0 as it is along the same line of the projection. Hence, the equation of y, that is ut sin theta minus gt square by 2, will be taken as 0. And from that we will get that equation for time t. It is equal to 2u sin theta upon g. Then the horizontal range. What is this horizontal range? That horizontal distance covered by the particle from the point of projection up to the point of landing. Here this one is the point of projection and this one is the point of landing. So the distance between these 2 points is defined as range r. Hence, to get this range r, the equation of x is used, that x is equal to ut cos theta. In this equation, put this t is equal to the equation for time of flight, that is 2u sin theta. And by putting this term, we will get x is equal to u square into sin 2 theta upon g. This is referred as the horizontal range, means the maximum horizontal distance covered by the particle. Next to this horizontal range, there is the term maximum height, means that vertical distance between the point of projection and the point where the vertical component of the velocity is 0. How do we consider that velocity? Velocity is tangential to the path covered by the particle. Here we can see that velocity at any point we can define or we can show the velocity. Velocity is always tangential. So at this point where it is reaching to the maximum height, velocity will be only along x direction. Hence y component of the velocity is becoming 0. That is why to get this maximum height, we are putting Vy equal to 0. So the equation of Vy was u sin theta minus gt. Just equate it with 0. So we will get t as u sin theta upon g. It is exactly half of the total time of flight. In the previous equation, we saw that total time of flight. Here the time we are getting exactly half of that. Now, as we are finding out the maximum height, it is distance along y direction. Hence now use that equation of y, and in this equation of y, put this time as u sin theta upon g. So by putting this term, we will get that y max, that is the maximum height, it is also referred with letter h. It is equal to u square sin square theta upon 2g. Then next to this, there is the another equation, that is equation of trajectory. Means it is the path traced by the projectile during its motion. That is from this point of projection up to the point of landing. Whatever is the path is traced by the projectile or by that particle, that for that path one equation can be derived, and that equation is called as the equation of trajectory. So how to derive that equation of trajectory? Let us see that. So for that equation of trajectory, we are just using first equation of x. X is equal to ut cos theta. So by this equation of x, we can get it in terms of t, that is t is equal to x upon u cos theta, and then we go to equation of y. Y is equal to ut sin theta minus gt square by 2. In this equation of y, put this t is equal to x upon u cos theta. So by putting that term t is equal to x upon u cos theta, we will get that final equation as y is equal to x into tan theta minus gx square into sec square theta upon 2u square. Here this second term can also be written as gx square upon 2u square into cos square theta. In either of the term we can use that equation. Now means this equation is in the form of x and y. That position at any instant can be found out by using this equation of trajectory. So these are the some of the terms which are useful in the projectile motion. These terms you can use to find out the different terms related with this projectile motion. Here in this total path, suppose I want that position at this point, so I'll name it as x and y, and in that x and y, then this values of theta and then that initial velocity will be put, and accordingly that equation can be used. So let us solve here one numerical related to the same concept. So here this statement is given that a projectile is fired from the edge of 150 meter cliff with an initial velocity of 180 meters per second at an angle of 30 degree with the horizontal. So by this statement we can get that 180 meters per second means that is the initial velocity which we are referring to u. Then angle of 30 degree with the horizontal means it is theta, and from the edge of 150 meter cliff that projectile was fired means this one is the origin. From here the projectile is fired, but this projectile is covering this distance, that is it is reaching to the ground at this point means it is covering the distance of 150 meter below the point of projection. That is why this y distance will be taken as minus 150. And based on this given data, we are asked to find out the horizontal distance from the gun to the point where the projectile strikes the ground. Means from this up to this point, that horizontal distance x is to be calculated. And secondly, the greatest elevation above the ground reached by the projectile. This one is the ground level. So above this ground level, that greatest elevation we are asked to find out. So let us see how to solve this problem. Let us go one by one. First one part we will consider that we are asked to find out distance x. So for that x, this much is the data available which is given in a question, that initial velocity, angle of projection and y. So based on this, now to get that horizontal distance we have two options. Either we can use that equation of range or we can use the equation of trajectory. But it is always better to go with the equation of trajectory, because this equation of trajectory, it is the quadratic equation in terms of x, means it will give you two possibilities of x. But if you are using only that equation of range, then it will give you only one answer, and that equation of range is derived only for the condition when that particle is landing in the same line as that of the point of projection. In our case, that particle is going below that point of projection. So in this case, it would be better to use this equation of trajectory, and hence we are using this equation of trajectory where x is unknown and y is minus 150. So this equation is written over here. In this g, it is the acceleration due to gravity 9.81, theta is the angle of projection 30 degree, u is the initial velocity 180. So putting all these terms together over here, it will be the equation in terms of x. So we will get two values of x. One is 3126 meter and another one is with the minus sign. As that distance cannot be negative, the second value is neglected and only the positive value is considered. So here we are getting that range as 3126 meter, which is the maximum horizontal distance covered by the particle. This is the answer for first question. Then second question was asked to find out the greatest elevation above the ground level. So now to find out that greatest elevation above the ground level, we will use that equation y max, that is the maximum height. But when this maximum height equation was derived, that is as u square sine square theta upon 2g, it was taken again from the line of projection. And now in this problem, we are finding out this elevation from the ground level. So from ground level, it is covering a distance of 150 meter plus the distance above the line of projection. Hence, this greatest elevation is taken as 150 plus 180 square into sine square theta upon 2g. And by solving this, we will get that answer for h as 562.84, which is approximately equal to 563 meters. Like here also you can see this is the ground level, and from this ground level we are asked to find out the distance. So, and whatever that h max we have taken, that h max is from this point, that is from the line of projection. Hence, we have considered this greatest elevation as h max plus this remaining 150 meter. And accordingly, this total elevation is calculated. So likewise, we can make use of these different equations and we can find out the related things to solve that projectile motion or to get the answers for the projectile motion. Thank you. If you have any query, you can mail me and I can solve your queries over here. Thank you once again for listening this session.